we have two demos. One, we're going to discover a 0-day together. And the second is we're going to run attacks at scale and mix application traffic with it. We're going to find one problem and then see how that could potentially be expanded to run the same thing at scale. So maybe we'll start with, we'll discover a 0-day by maybe hacking into one of your bank accounts. So anyone want to volunteer? There.
I volunteer Foscus.
Somebody with more money would be better than less money.
Just before we get into the demo, I have another 35 slides to cover. No, I'm just kidding.
So let's switch.
Yeah. They're all customer logos.
So let's switch to the demo. I'll run it off this machine. Well,
yeah.
You can run it off any browser. So if you have Chrome,
yeah.
On your side, yeah.
That same target, but I think I have it all open.
Yeah.
Ashwath, I think we can start.
Yeah?
Yeah.
Okay. So, so what we have here, we're going to run discover a 0-day, not in your bank account, but in Jabber. So people know what Jabber is. Jabber is the instant messaging software. So you're going to use that because it's a nice contained demo. We can run a fuzz attack and find a new vulnerability in there. So I'm going to first start, really show you a bottom-up demo. And start with making sure the network configuration is good and I'm able to connect to the target and all of that first. So I have the interfaces defined here, v4 addresses, I have the routes defined. Let me go to the host and make sure that the target is up and running. I'll connect to it over SSH and okay, so that target is up. Okay, and I'm going to run Jabber on this and bring up the Jabber server, right? Then I'm going to switch back to my system and bring up a test. I have this test, and I'll talk to you about how you create the test as well. But first, let me show you the test. Running it, finding the problem. Then we'll switch, and there are a couple of ways, 3 ways in which you can create the test. You can use the one we provide, or you can start with your own packet capture. You can start with a what we call an HTML archive file. If you have a web app and you want to capture the interactions there, you can do that as well. So multiple ways to get into the system. So the what we have here is a test run, and the Jabber register application is what is going to talk to Jabber. And remember, it's going to send valid messages, make sure the target is responds back. It thinks that you're a good guy. It says you say hello, I say hello back, and it goes back and forth. And then I'm going to methodically step through the fields and check everyone. Try to muck with one and see if you still respond. So it's going to do health checks as we go through it, and boom, at I think it's the 47th test, it crashes the system and restarts the system. And I have something called a restarter here, and the reason we have that is to automate the whole process. Once you crash, I want you to come back up so I can punch you again and see if there's more vulnerabilities in there. So let's do the verify and make sure the network connectivity is there, and then start the fuzz test. So what it's doing is it's going to send what we call an instrumentation to send the Jabber message. If it does a ping, then it does. So this came up green, and the restarter really is basically going to a target and is doing a restart. It's just sending a simple command that says clean restart, so it restarts Jabber on the target. Okay. So then I'm going to run the test, and it's going to send a Jabber register message. And this could be anything else. It could be a SIP message. It could be an HTTP web request. It could be a protocol. It could be, you know, any sort of interaction over IP. You can bring into our system, and you can create, you know, you can start discovering vulnerabilities using it.
So is it fair to classify this as like a penetration testing tool? Or
It's like that. It's just that it's completely automated. Typically, pen test tools need an expert to drive it, and you need to know what the target is and then run a series of tests that match the target. This is a completely automated way to go hit a target. All you need is a packet trace or an HTML archive file that I'll show you. And you can bring it into our system. We auto-generate using our library all the possible attack vectors and then go through it systematically one by one to find the problem on the system.
Does this tool have an agent that actually runs on the target to look for things like, look at the process
CPU.
and see if it goes beyond a memory boundary?
Yeah, so what we have these things called monitors. We have an SNMP-based monitor, we have a command monitor, we have a protocol instrumentation monitor. So as you're testing HTTP, you could measure the health of SIP or some related message. The way you do CPU and memory is you'll run a command monitor. You'll log in over SSH or Telnet or something, and then just run your favorite commands, top or whatever you run on your target, and you can get the results and feed that back into your test process. So this is running, it's at 42, there's nothing happening on this side, but once it gets to 47, you'll see, boom, it detected a problem. And this is with an overflow message. It's going to, when it's sent for a Jabber request field, when it sent more than what the target expected, it caused it to restart. And we check it 3 times to make sure we can bring it up, hit it again, and cause the target to crash all over again. And this could, we found problems in multiple areas, not just Jabber. We found problems in really popular web servers that lots of IT departments use. And what we've done is the right thing. We've gone to the vendor and told them, hey, you have this issue. It's a 0-day, go and learn how to fix it.
So are you seeing this implemented in the conjunction of like some larger enterprises are starting to have full, at least functional testing of their networking and sometimes getting in security content switching environments as part of the change control process? Are you seeing it integrated as an evolution of that, of running through synthetic transactions or fuzzing the application, or is it more integrating with your daily builds with your app team?
So you could integrate it with your daily builds and app team. Typically, it's done in a development environment,
yeah.
And people also do it before they introduce a new big change. They want to make sure that it doesn't have any major flaws that are going to, cause a new weakness to come in.
And this gives a whole new definition of who broke the build, right?
Right,
Yeah.
right, exactly.
Yeah, and you want to incorporate that in your whole build process so that it gets caught as early as possible. And you don't know what you don't know. That's why you do the fuzzing test.
Yeah.
You still want to, as he said, it's automated, so it cannot be completely random. It still has boundaries of the structures of messages, what it can tweak, but it has enough intelligence that it can bring hundreds of thousands of different test cases or different aspects of change, which are not like just random. It's not like completely dumb testing. It's automated, but it's smart automated, so that it gives you more likelihood of getting a positive of something wrong in the build.
Yeah, so and actually a good question. Do you have this integrated into development test suites? So you do a nightly build, but there's some suites that actually think of like Garrett that runs tests, runs automated tests when you're checking code for open source projects. Do you have it integrated into? I guess Garrett doesn't do that, but are these integrated?
So there's RESTful APIs that we have into this. So you can integrate it from things like Bamboo, or if you have other automation components. Atlassian has a product, and there's multiple people who have products. So it's everything out here is a JSON object or an XML object that then gets fed in as a command to start the test. So people have integrated it across multiple frameworks. Some of the traditional NEM users use Tickle. Some of the more modern, shops use things like Ruby or Ruby on Rails. So there's a variety of ways to get in, but everything at the end of the day enters our system as a RESTful HTTP call. And once you find a target, that's half the problem. Finding a target is one piece, but finding a fault is one piece, but how do you remediate it? And that's the other half. How do you go about reproducing it and fixing it? And we have a remediation toolkit that goes in and shows you all the information you need to remotely diagnose the problem. A lot of times, you have distributed organizations. It's not the same place where the developer is and where the tester is or where the end user is. So we give you all the capabilities needed that can be exported, an XML file for the test, a PCAP of what was going on during a test, what we call a vulnerability trigger. It's basically a Linux executable that you can ship into your bug tracking system. And whoever gets it on the other end just has to run that to reproduce the problem. So we give you a report. We give you all this capabilities to fix the problem quickly and then rerun the test and see if the patch works or not.
Yeah, because it's also key to find out what actually made it crash. It's not just, okay, I crashed it. So what intelligence did you get out of it? That's where all these tools help, all these capabilities of the PCAPs, so that you can reproduce it. You have done it. You know that it can be done again, so that you can go and fix it.
So this seems like this is a tool that you can run against something that's listing a server service or something.
Right.
Does it offer any way to test a client, something that's not listing, something that would go to request something from a server, say a web browser or something?
Sure. So the way you can do that is a little more involved, because you need to do a bit of automation to tickle the client to make a request, right? So I could be acting as a server. I go off and say, hey, make the request to me, and as long as you can cause the client to send in the request, the server can send bad stuff back.
Okay.
But it's a bit more involved, but it's doable.
You have any kind of post-mortem analysis? So you've been exploited, the bot's been booted, and go back and look for replays or anything like that?
Yeah, so we have some software that we've released, which is called Extractor, which does a forensics analysis on PCAP. It takes a large PCAP, multiple gigs of it, and then it converts it into a free text searchable index that you can then say, okay, I want to have multiple points I can jump off at. I want to jump off at the IP address or the port number or the protocol or something in the payload, and you can slice and dice that large PCAP to get closer to what you think the problem area is. And it's not automated in the sense that you need someone who knows what he's looking for to he or she to find the problem, but we give you tools to make the problem easier and make it more tangible. So that's one piece I wanted to show you on finding a new vulnerability, a new 0-day. The other is I wanted to briefly show you how you create a new test. We provide standard protocols. We provide those attacks to you. But let's say you had your own. Let's say you had your own. Close this and open a new one, right? So let's say you had your own website that you wanted to test, and it uses SSL. So you need to capture the transaction before it hits SSL, and then create a test out of that. So what you do is we have a plugin. You could just go to Google, and you have this Firebug plugin that pops up. And if I'm searching for something, let's say I'm searching for Obama, that is getting captured in there. If I'm searching for, Romney tax returns. Okay, so if I'm searching for something, I get the messages coming back. And I can save that off as an archive file, save off as a HTML archive file. And that can be imported into the system, and we'll create attacks from that transaction. So it can be any HTTP-based target. It could be a PCAP-based interaction, and we can create tests automatically from that. So that was one piece. The other thing I wanted to show you was how you can scale it. You found one attack. Now, what if you wanted to make it 100,000 attacks? If you wanted to make it 1 million, of those attacks, and mix it in with application traffic. So let me, part of this is I'll show you Test Cloud. We talked about Test Cloud. So you can go in here and say, hey, I want to download business systems. You know, I want SharePoint. And you have different versions of SharePoint. And you can download that. So you can say, I want Skype. And I've got all these different versions of Skype on different platforms. You know, I have Skype on Android and MacBook and PC and iPad. So I have this Test Cloud which has thousands of application samples and attack samples that I can pull from and then recreate a mix in my lab that's a mix of apps and attacks. So down here, this is a pretty simple drag and drop interface. I can say, okay, let me look at the attacks that are here and drag that onto my track. And this has, you know, IBM, Tivoli, Endpoint Manager, cross-site scripting attack, or other types of attacks that we've added to Test Cloud that you can access. You can also go in and say, okay, now I want to add an application sample. So let's go down and pick, say, new business systems, right? And this has Trend Micro and Symantec and Oracle and things that you would see that are valid traffic. So I've got valid traffic and I've got the attack traffic. I can, you know, using just a little button here, I can say, okay, how many connections I want of the target, of this mix. I can change the percentage and say, somehow this.
It's on the right. It's right here, but it has not updated yet. Yeah.
Oh, it's slow for some reason.
Yeah. Yeah, it's not updating. You go back and forth, you'll probably get it. Go to the store and come back to the player.
Okay. So I can change this. I can even change the weights to say I want 40% of this or, you know, 80% of the other. So I can have my mix of applications and attacks and up to 8 tracks. So I can do business, I can do gaming, you know, whatever mix I see in my environment, in my network. And I can change the, I can control the test by connections, by bandwidth, by the connection rate, or by the concurrency. And as I said, you know, application performance and security are two sides of the same coin, so you can have the mix that you think is appropriate for your test. And then you just hit go, and it loads all this onto the target system, which is a test system, and then hits the firewall and loads it up and runs it at scale. So you had one vulnerability, you can now make it, you know, 1 million if you wanted, and see whether you're able to still withstand that attack.
Yeah, and also the application side of the story, as I mentioned, nowadays it's much more complex with so many different endpoints. So in the past you would have only one software update. Nowadays you have one software update for iPhone, one for Android, one for your PC, one for your Mac. So there might be, you know, at times somebody just issued a new update. It might be fine for all the platforms except one. So there are like those kind of aspects also when it comes to testing, as opposed to just having, okay, here's a new software update, that's it. So now the number of endpoints are more, number of different versions of software coming out are much more frequent now. Like every month or two, you'll see any popular app having a new version come out, versus in the past it would come out much less often. So that also adds to the mix of traffic you can see in your network. So it might be like a single software has 3, 4, 5, or even 10 different versions running at the same time on your network. And how does that impact? And how does that make you track? At times, IT says, okay, we only support this version and up. Everybody has been updated. There was an example of that. One IT guy said, oh, we upgraded every system. It is only this version of Windows and up. And as soon as we started sniffing, it's like, oh, okay, here you go. Here is a pretty easy definition of somebody using an older OS. So that's another aspect you need to be aware of.
So the first demo was against an endpoint, a live target. This one is more of where we're playing client and server with something in the middle, like a firewall that should have detected that attack and stopped it. And we're acting as a client and server, having multiple clients targeting one or more servers. So there's flexibility on that front as well.
So what's the form factor of this product? Is it a virtual server?
So the controller that you're seeing here is a VM that can control one or more appliances. We can run it on the chassis, which is what we're trying to do is architecture is separating content, which is in the cloud. You know, we have a Heroku-based, Amazon-based system that we add new tests to. So the content is separate. The actual controller that runs the test is a virtual machine that can, you know, that listens to the cloud, downloads new tests, and runs the attack and has the test reports and all of that together. And then the actual execution can happen on any. We've, you know, cut that out. So it can happen on a chassis, which is a Spirent Test Center chassis. It can happen on what Tim was talking about, you know, with his machine, or it can happen on a VM server where, you know, we have in the Juniper Junosphere virtual environment, we have it running on a KVM instance. We can have it run on a 8010 or 8000 piece of appliance-based test gear. So we've made sure that it's modular and can run on different targets, depending on what the consumer wants to deploy.
Will it run? Will it run on one of the new Axon?
Yes, I mean not in the first release, but yes.
Okay.
So this already runs on the Spirent Test Center C100 platform, which used to be the Avalanche platform. Now it supports Avalanche as well as this solution. So it was impressive that the speed with which we were able to harness the power of existing hardware and have this solution on top of it.
Yeah, it's all software. It's all Intel-based software. We don't rely on, you know, special hardware for any of this. And the report goes into, you know, details. If you want to look at it from a block miss standpoint, or you want to look at the number of bytes sent and received, throughput, connections, you know, connections per second, breakup of, okay, you know, what the Jabber percentage was versus IBM Tivoli Endpoint Manager attack versus other things. You know, it gives you a lot of details on, you can go deeper if you want when you get to the report. And there's an API, very strong API interface that lets you, you know, load up the JSON file or the XML file, run the test, get the report out. And our goal has been, you know, take security out of the hands of the experts, make it accessible to people, put the expertise into the product that we're selling. So you can take a packet trace or a HTML file or some other transaction, and we'll generate the security test for you. And you want to run it one by one, that's fine. You want to scale it up, that's fine. You want to torture a target, that's up to you.
So I think this was the second demo which we had to share. I think we have another minute or two for Q&A if you have any other questions for the entire session which we were talking about. Yeah.
Yeah, so I mean, there's a lot of front-end applications here, a lot of client applications and server applications. You know, a lot of the new stuff coming out is really exposure of RESTful APIs.
Right.
Are you building out test suites for kind of that area, which frankly is not well tested in my opinion?
Yeah, yeah. So, you know, the Cloud Security Alliance, I think they said the number 2 or 3 test, I don't remember the exact number, it was high, was about cloud API security. People are really concerned that RESTful APIs are a way in which you can, you know, most easily reach a target and test it. Yeah. So you can take in and the issue is as you get lower down the stack, as you get to the protocols, yeah, things are RFC based and very well defined, or, you know, if not even well not defined, it's you know, more or less standard. So you can create a test suite, a conformance suite, or something else that tests all the flaws out. Yeah. As you go higher, it gets, you know, pretty complex pretty fast, which is why we can provide you an HTTP test suite. Yeah. But once you want to go higher than that and test SOAP or test, you know, XML or test a RESTful API, yeah, you need to bring in your content. And we will use our smarts to generate the test cases, but because it's custom to your target, all you need to do is do the capture, bring it in, and we'll recreate the test and run it.
I mean, in a very specific use case, a couple weeks ago, is extending, or actually it was 6 weeks ago now, it's extending Nova API with some extended to allow extended attributes, which, you know, started on a whiteboard, was hacked together, and some code gets contributed.
Right.
And absolutely. You think of the functionality that is, you're adding a whole bunch of functionality, but expanding a whole bunch more threat vectors.
Mhm.
Yeah.
Mhm.
And
Exactly.
to your point, it's not like ITF where
Right.
you spend 2 years arguing about if, then, what, or will.
Right, right. So there's two levels to that, right? The first level is, this our CTO talks about the 6 degrees of separation when it comes to messages and protocols, where the same fields get reused across, or similar fields,
Yeah.
type length value fields, attribute fields
Yeah.
get reused across implementations, because engineers have done things in the past and they take it forward, and when they bring something new, they rely on the design principles of the past.
Still your
So
code.
we can exactly. So we can build attack vectors that will apply to as yet undiscovered messages by bringing in the trace, by recognizing the fields and the structures and the relationships between them.
And very specific, I'm trying to think like inserting that into a code review cycle. You're saying so you could, if we're running the code test, if you guys were either inserted programmatically into the code test, so you guys are sniffing the responses and the different APIs,
Right.
Mhm.
you would emulate that and then fuzz against that
Pretty much, yeah.
and
Exactly.
automate and pop a
Yeah.
report back and maybe even integrate it in the code review process.
Yes. So it could be integrated into a build process, and you could do
Yeah.
this,
And
Yeah.
literally the output that you had, maybe that one's
Right.
probably not email friendly, but that output would be part of the automated review process before it hits a
Yeah.
human reviewer.
Yeah.
Yeah.
Yeah, cool. That's pretty
And
cool.
that's when you're taking the custom conversation and then fuzzing on that. So that is a little more appropriate for that cycle of testing.
Well, thinking like a huge risk, and enterprises start to do this too. Taking these products, think of even what's called, the enterprise products, vCloud API or the VMware APIs and whatnot. You're putting API brokers in the middle, and they're enhancing, extending features to
Mhm.
be able to,
Right.
actually test this.
And we have, in addition to the automated stuff, we also have the ability, we have an editor. So if you are a hacker or have tendencies towards hacking, then you can take that trace and
Bad hacking or
Yeah.
code hacking?
code hacking.
Code hacking.
So you can actually go into the editor and create your own, bad stuff.